Okay, I'm back. All right, I have a joke for you. What did the big flower say to the little flower? Hey, bud. Okay, so now I want to talk about weak acids. So weak acids are everything that begins with an H. Sometimes they don't begin with an H, but anything that is not a strong acid. So, for example, let's just take HNO2, which looks a lot like HNO3, but it's not. It's a weak acid. So this is a weak acid. So weak acids, we have to do a little bit more work in order to determine the hydrogen ion concentration. So say we have a 0.1 molar solution of HNO2. We cannot say that the molarity is equal to that. So that is not the case. So what happens when we have a 0.1 molar solution of a weak acid, or any concentration of a weak acid, we end up getting into an equilibrium situation where we have a certain amount of hydrogen ions and a certain amount of nitrite ions. Now, because this is a weak acid, you hardly have any of these. So you could actually have, say, 100 HNO2 molecules, and you could end up ionizing into one of these and one of these, which then would obviously turn that into 99. So you essentially, when you're drawing or writing a weak acid, you keep it together because it does not really break up at all. Okay, so in order, however, there is some ionization, so we have to determine what the pH is based on the hydrogen ion concentration. So the way we would do that is with an ice table. So we would have to know the Ka, which would be the equilibrium constant of the acid. So we've done a lot with a KeQ, but now when we specifically talk about an acid, we talk about a Ka. So if we do a rice table, our reaction, which isn't really a reaction, but it's an ionization. Sorry, I shouldn't have put that there. Okay, breaks up into hydrogen ion and nitrite. All right, so I told you we had a 0.1 molar solution initially. Here we have nothing. Here we have nothing. Excuse me. The change is going to be minus X plus X plus X. And then 0.10 molar minus X, X, X. So we would write the Ka as, again, the concentration. And again, make sure you write all of this stuff out for the exam. Sorry, it's getting a little messy. And then we would plug our numbers in, x squared over 0.10 minus x. So for this type of problem, you would be given the Ka, and then you could go ahead and solve for x. Now for every weak acid, the good news is you can use the simplifying assumption because the Kas are going to be very small. So you can get rid of, whoops, sorry about that. You can get rid of that x, and it makes it much easier to solve.